Thank you for joining this lesson. We're going to discuss waves 1. Remember to subscribe and to share this lesson with friends. The figure below shows a wave in progress. So the wave is displayed on the figure. We have on the vertical axis, we can see there is displacement in centimeters. Then on the horizontal axis, there is time in seconds. The units are very important. Determine thing, part 1, amplitude. What we should know is that amplitude, abbreviated capital A, is the maximum displacement of particles from the mean position. So this is a transverse wave in nature, whereby the particle is being displaced perpendicularly to the wave motion. So from the mean position, this one is the mean position, the axis here. This one is the mean position. So now with the mean position, we can identify the highest or the lowest a particle can go. And according to the scale, it is only 2 centimeters. Therefore, because amplitude is a displacement and should be given in meters, then we can write it in SI units. Instead of 2 centimeters, we can write 2.0 multiplied by 10 to the power of -2. Then we write the SI units as meters. That is after dividing by 100. Number 2, determine the frequency of the wave. Let's go back to the wave motion again. We are now determining frequency. On the horizontal axis, there is time. And from time, what we can interpret is what we call periodic time. Periodic time is the time taken to cover a complete oscillation. Then an oscillation is between, a complete oscillation is between two particles which are in phase. For instance, from this crest until we meet a crest again, that is from 2 seconds all the way to the 10th second. Therefore, there is a time interval of 8 minutes, 8 seconds, that is. So now we can say periodic time. Or rather, we can even consider any other particles which are in phase for us to know the periodic time. Even from 0, if a particle moves until it is at the same point of displacement and moving in the same direction, then we will say that is a complete oscillation, or rather, it's a wavelength. So from this point, show you what I'm saying. From this point, if a particle flows until it is at the same point again and moving in the same direction, then the particle has covered a complete oscillation. So we can say that from 0 to 8, there are 8 seconds. So we can determine periodic time as long as we have considered two particles which are in phase, then we consider the time interval between them. All right, so we can see 8 seconds are the periodic time. So periodic time T equals to 8 seconds. And we know that there is a relationship between frequency and periodic time, and is that one is the reciprocal of the other. So 1 out of 8, this will give us exactly 0.125. This is hertz. These are units of frequency. This can also be determined by, alternatively, we can also determine frequency by looking at the wave again. We are given time intervals until the 12th second. So when we consider from 0 until the 12th second, we can consider the number of complete oscillations covered in such a time interval. Therefore, from 0, we can see there is a, let me use a different ink now to show you the wavelengths. So from this point all the way to the 8th second, there is a complete oscillation. Then from there up to the 12th second, there is half a wavelength. So we can see in 12 seconds, there is a total of 1.5 oscillations. So we are saying 12 seconds are being taken to cover 1.5 complete cycles. What is the number of complete cycles in 1 second. So in 1 second, we shall have how many cycles? Because we usually say the number of complete oscillations per unit time is the definition of frequency. So we can determine the number of complete oscillations within a second. This is going to give us 1 multiplied by 1.5 divided by 12, and exactly we are getting back to the same answer, 125. This is going to be hertz. So that is the calculation of the frequency. Thank you so much for following. Subscribe and share.